Let's wait 1 more minute. Let the people join. Then we will start the session.
Hi guys.
Sir, we can ask doubt in last also, right?
Yeah, okay. So, yeah. So
Okay,
the
sir.
plan is, let me finish the revision thing quickly. For I will try to finish week 1 and 2. The next revision session, in the next revision session, we'll cover the week 3 and 4.
Yes, sir.
Okay. Please, everyone, mute yourself. Mustafa, want to say something apart from the doubt?
Sir, this revision is week 1, week 2, week 3, week 4, or just a specific week?
We'll try to cover in 2 weeks, because all weeks will cover it's difficult to cover them. Okay. So, and the next revision session will cover the week 3 and 4. Okay.
Yeah, this is Mustafa. So my doubt was about week 4 practice assignment. Is it the right time to ask, or you will...
Yeah, later we'll try
Okay.
to, like,
Okay, great.
yeah.
Thank you. Thank you.
I think there is one session on week 4, remain one session also, right? I think, just let me check once. This is 22. Okay. Week 4. Okay. We'll see later. Okay. Okay. Just a minute.
So this is revision session, huh?
Yeah, this is revision session. Math 1 first revision session.
Okay. From week 1 to week 4, right?
Yeah, we'll try to cover 2 weeks only.
Okay.
And the remaining week will cover the next revision session on, it is on, I think, Friday. This is on Tuesday, next is on Friday. Okay, so
which 2 weeks we are covering? Third or fourth or first, second?
yeah, first 2 week we'll try to cover. The next 2 week will cover in the next revision session on Friday. Yeah, Jessica wants to say something.
Yes, sir. My doubt is from practice assignment week 4.
Okay, so doubts, if you are a specific doubt, I thought you have general doubts. The particular weeks or doubts we'll try to cover in the next, like in the last of the, after completing this revision session.
Only week 1 session, week 1 doubts are considered?
After revising the week 1 and 2, we'll take the we'll take the doubts.
Let this be a revision. Actually, I joined this for revision only.
Yeah.
Revision. Doubts.
Okay, so this is week 1. Okay. So we'll start with the natural number, and on there, like one by one, we lecture wise we'll try to cover very quickly. Okay. So natural number, you
Write
know,
down.
in this.
Please write down my doubts from week 1.
You
So
can
after
provide your doubts.
after watching this, yeah. See, already we have the office hour. If you have a specific doubt on a practice activity, you can ask in the next office hour is daily at 11, at 1:30 and 3:30. So you can ask there also. If once we finish this revision session, otherwise you can ask in the last of this session.
Yes, sir.
Purely revision.
Okay, so in this course, natural number in this course we are considering, this should be note here, we are considering it is started from 0. From later, like in the, like for the maths one, it is, we are thinking natural number start from 0, but from the next maybe some other courses maybe have convention that yeah, they will start from 1, but for maths one it is at least for 0 we are considering it. Just a minute. Okay. Then there are, after natural number, there are rational number. Rational number are those numbers which you are able to write in the P by Q form, and where you can think, where P and Q you can think as a co-prime. Co-prime means sorry.
Sir, can I ask you the same question about this only, rational number?
Yes, sure.
Sir, why root 3 by 2 is not called as a rational number, or like
By
root
root
3
3?
by 2? So when we find the question like find the rational number, irrational number, so we always try to do component or dividend and try to make it into like something like which is
why
not in
root,
the under.
root 3 is not a rational number. This is this question.
Yes,
root
sir.
3.
Yes, sir.
So already see there is a process assuming to be like this is a P by Q and take the
But
square root.
sir,
Like, yeah.
Yeah, but sir, always 1 is below that, right, in denominator. So I wanted to know why when the under root comes, then it is not called as a rational number.
Okay, so you are thinking this is
Root 3
3
plus
by
2,
1
let's
is
say. Yeah.
okay.
Why
So
this
is
is
this,
not called?
so what about this P? What is then P? What is P here? Now P is what? P are
Numerator?
integers, right? You
Oh,
can
it
take the
should be.
integers. But
Okay,
here what
okay.
is it? Is this integer?
No, no, no.
No.
So
That's why. Okay. So it
that's why
should
you
be
can think that,
integer.
yeah, you
Okay,
can think these are the integer. Okay.
okay, okay, sir. Got it.
So after the rational number, there are irrational number, as just now we discussed. Irrational number are those number which you are unable to write in P by Q form, where like this is P and Q are, you can think from integer, where Q should not equal to 0, and like the irrational numbers are root 2, root 3. Why these are the irrational number? You can think also, if you take this root 2 as a, like in the point form, in the just like 1.2 point something is there. So these numbers are continuously, like it is not form a pattern, like it is not a repeat, it will not repeat the numbers. It will continuously will change. Like if here is 1, then here it will be 2 or 3. It will always change continuously. So that's why you can think you are unable to like form, like you can think that, okay, so that's why you can unable to write these numbers and P by what happened in P by Q form. Okay, so these are the irrational number. You can think there are not only the roots or There are some number like log 5, you can think that it is irrational or rational, you can check with the P by Q while thinking it. We'll later do because these numbers are, if you're not done with the exponential, then such type of question will not ask to be like these numbers are rational or irrational. Once you will done with the exponential, then these are numbers are easy to deal with that. Is this rational or irrational? Okay, so next is after doing rational and irrational, we'll quickly move on to, so these are, there are, including these numbers like natural, rational, integers, irrational. If you
Excuse me,
include,
sir.
take the union of all these, yeah.
Sir, I have a doubt in that mock test. The answer was minus 24. So how is it a rational number, sir? Minus 24. Can you please explain?
Okay,
You can write minus 24 is equal to minus 24 by 1.
yeah, minus 24 is why irrational number, or minus 24 is rational.
Rational number.
24 is an integer.
Yeah,
It's an
So we
integer.
can write
na?
in 24 by 1 is equal to
real.
P by Q.
Okay.
yeah, minus 24 is a, this is an
Integer.
integer,
Yeah.
right? And minus 24 is, it is, you can think this is always to be written as minus 24 by 1.
Yeah.
And this is an integer and this is also integer. So this number could be written as it is already written in the P by Q form, where Q is not 0 and P and Q are integers.
So we can say it is rational number.
Yeah, so this is a rational number. So all
Okay.
natural number,
Rational.
integers and rational number itself, you can say those are the rational number as the definition. Irrational number as the definition is given. And real number. Now if you include, the next thing is real number.
Okay.
So real number is actually, you can think that it is a union of rational and irrational.
Yeah.
Okay, this is a, if you think that this is the set of rational number and this is the set of,
Irrational
let's
number.
say this is Q and this is a set of irrational number. Okay, so that is generally denoted as Q complement. Q rational number are generally denoted with the Q and irrational number are generally denoted with the Q complement. So if you take the union these two, the whole number is actually real number, you can think of. And generally we denote, or we think this is a real line and all numbers are on this real line. Okay. So this is all about. Next thing is, the main thing is on, we are going to deal with the set theory and relation. Now let's move on to the set theory. Set. So what is set? Set is nothing but a collection of objects, well-defined object. Okay, so what do you mean by the well-defined object? Means if you think as if you are thinking the collection of wise people or intelligent people, then this term, the wise or intelligent people, is not defined properly. Well-defined means not defined object. Like wise people, how you will say, how a person you can say this is wise and this person is not wise. So set is actually that sorry. So then set is, now you can say, a well-defined object. Here is, if you are thinking the wise person or intelligent person, so each person is have different ability to do, or wise, whatever you can say, or differently you can say, or not well-defined object is, anybody can unmute and tell that any other example.
Sir, I have a question about that.
Mhm.
If I collect a collection, some integers, some players of Indian cricketer,
Mhm.
and then we said that all the sets are all defined set.
Yeah, if you are collecting, if you are thinking, let's
No,
say,
sir,
yes, it's a
the
set.
single
So
set. 1, 2, 3, and then Virat Kohli, Rohit Sharma. It is continue to this way.
yeah, Virat Kohli and all 11 players of
Okay,
a
sir.
particular
Then how
particular
to
team.
so then how to write this set builder form? This
So it is now difficult to write a set builder, like set in the
then
set
this way
comprehension.
Yes.
Yeah. So yeah,
Then
now see, if you, so there is another term, like if now once we know the well-defined object, okay, the set is actually the collection of well-defined objects.
So
Okay.
this set is not well defined. This is
Yeah,
not.
these are the numbers are like this. These are 1, 2, 3, and some number. Let's say till 5. You are taking it.
So this S is not a set.
Yeah, this set is this collection of this collection of these things are is actually well-defined, and this is just set.
Sir, but we cannot write the set builder form. Then
No, so each see everything you cannot write like everything is like now you are saying like I'm just writing the like each set can be not easily written as the set like set comprehensor or set builder form, right? If you are writing in the if you are writing in a set as a set comprehensor or set builder form, so like it is you are able to write like you are defining like this. Suppose let's say I'm saying that this is a set where I'm collecting the square number of natural taking the square of all natural number. This is the collection of set which is, let's say, 1 square of 1 is 1, 2 square of 2 is 4, like this. Okay, and square of 3 is 9. So this is see, you have a pattern, then you are able to write this set as saying to be you are taking n square such that n belongs to n. That's all enough to write this. This
so
is
then what is the difference between these sets and above sets?
this one and this one.
Yeah.
So these two are same. Like this is written as the in elaborate form, and this
Yes.
is written as the set
Yes.
comprehensive in the form
First
of set
one,
comprehensive.
where is the some integers and some Indian players, and here is the squares of the numbers. There are two different sets, and what is the difference between them?
No, this is the you are said. See, this is a finite set. See, generally, in a simple word, if you are saying, generally set comprehension is used for the infinite set, if you are thinking. And if
Yeah.
it is a finite, and if you are able to note it, like if you have 10 element, 12 element, so generally set comprehension is like you are able to just write those numbers, those elements. Otherwise, okay, if you are able, that set is if you are able to write that set as a set comprehension, that's you can write. Otherwise, this set you are unable to write properly in the set comprehension. That's all the answer for this. Okay, for this question, if you want to in the set comprehension form, it is difficult to write, or it is not how you will write. What do you mean? What from my side there is question. What is use of the set comprehension then? Why you want to write this set as a set comprehension? What is use of?
To filter out elements of a set?
No.
So there are two sets. One set is one set there is not written in the set builder form, and one set there is written in the set builder form. Then
Okay.
what is the relation?
To be
So
able
there is
to
no relation. I'm there is a question from my side. What is use of the set comprehension or set builder
to
form?
be able to
What is
like
It's a set builder form. It is the same.
That in a better way.
to be able to show them in a short form for, like, let's say there's an infinite set, so we can have a condition, then filter out infinite set of even numbers.
Yes,
Oh.
sir. Yes.
Yeah,
So
yeah.
that's the use of. That's the use of. Like if you are saying you are collecting the square of the natural number,
Yeah.
so this is not correct. You have to write the all natural number. So then here is use of the set of natural set builder form of this set. Otherwise, if you are able to note it, that's all. So the use of that, if you are unable to write in the whole element, so the best thing is just write in this form. This is also saying the same thing. This is the saying to the same thing, but here this is not correct because you are unable to write. If you are denoting, this is the collection of number, but this is not proper. You have to write all numbers here, square of all numbers. Then the term you can use the set comprehension. That's the use of set comprehension or set builder form of a set. As here the numbers you are able to write, here elements are able to write. That's all. Otherwise, each set cannot be written as a set comprehensor or set builder form. That's all. That's the answer. Okay. Now, the next thing is set operations are like, so there are, so set is nothing but a collection of well-defined object, and we done with the set builder or set comprehension. Means here, as we discussed now, we are try to write a set and in a different way, where we are unable to collect, we are unable to write the all elements. So that's why the use of set comprehension, and this is one form of the writing to be this set as in the set comprehension or set builder form. Okay. Now there are some operations on the set. So like operation you can include as union, intersection of two sets, mean to say union of two sets. You have suppose a set A, and generally the notation of sets is the capital letter of the, you can generally use the capital letter of the like this characters A, B, and C. So suppose you have two set A and B. So union of generally denoted as like this, and in the set form, if you write, okay, in the set form, in the set comprehension, if you want to write, so this is, you can say X such that X belongs to A, okay, or X belongs to B, you can say. Okay, otherwise not here, and you can need to replace, you can with the and, not and, or is enough. So mean to say you are collecting those number, those elements which are in A and which are in the set B also. You are collecting all those element. That's the union. And intersection is generally denoted with this cap thing, and it is
or indicates the union one.
Yeah, it is here should be or, and you can say or, and A intersection B is the collection of those element which is available in both. So X, this is the collection of element which is in A, and X belongs to B also. So now I'm not giving the example with, because these things are pretty much obvious. There is nothing, or simply if you think, let's say A is only one element and B is another, say let's see 1, 2. Say A union B is nothing but the 1 and 2. It is going to be the B itself, because if you take, you are not in the set form, the elements are not in the, can be written, means whatever the more element, the same element is coming, you can filter out, and only one copy should be there in the set. And A intersection B is the which element is common in the both set. So this is going to be set A itself. Now there is another set subtraction, you can say set A minus set B. So if you think set A minus B is the collection of those element in A which is not in B. You can yeah, those element, you need to remove those element which is in A, and also in B you can remove those element. Like here, if you want to remove this, if you, this is going to be set A minus B, so this is going to be empty set, because one is there, so one could be removed, so there is no element, so this is going to be your 5. And if you are thinking set B minus A, so this is going to be as you can remove the one common element. Which one is common, you need to remove those, and only this will come. And any other operations are there? A union, intersection, set.
Complement.
And there is another complement. So complement, whenever we talk about the complement, there is needed a superset. Okay.
Yeah.
So without that, there is no word to use of, like if you are thinking only just set A, this is. So, and you are asking what is the complement of it. So surely he will ask, what is the superset of this? Under which set you are thinking this is going to be your a set and you are thinking for the complement of this set. So surely whenever the complement word is used, surely there is a superset. Under that set, you want to take the complement of that set. So let's say the superset is as here A is, let's say A is a set, and let's say I am saying the superset is B, which is 1, 2. So complement of, if you think the complement of this set is now with compare of this set B, so this is going to be 2 only. So mean to say in the pictorial form, you can think, suppose this is the set A, okay, this is the set A, so complement of it is going to be this set outside of the whatever the element, those element which is out to that set, this is going to be your A complement. And union in pictorial form, if you say, so A union B is generally, suppose this is set A and this is B, so union is actually all elements will come in this here, and complement is, sorry, intersection is this element will come whatever is a common, and A set minus B is, you can think that, well, this is A and this is B, here is, this is A, this is B, so A minus B is going to be the collection of these elements. Only you can remove the common and whatever from this set, and B minus A is
The graph of A minus B is wrong, I think.
sorry.
The graph of A minus B, the circle.
No, it
Correct.
is not wrong.
It's correct.
It is
Correct.
correct.
This is
Correct.
We have to
correct.
collect only A elements, which is only in A.
Sorry, my pen is not working. Okay, so just give me a minute. Why it is not? Just a minute. It is not working. Now let's start. Okay, so when B minus A is the same, you can suppose this is A and B. So B minus A is, you all will connect
Hello, your voice has gone, sir, right? I think.
Yeah, actually just muted. This pen is not working. I'm changing it. Just a minute. I think it will work soon. Okay. Let's see. Okay. So B minus A is, this is out of whatever the element in A we will remove, common element remove, we will remove from B only. So this is B minus A, and complement I just given the graph. Okay. Now, after the set operation example, so example of set operation and counting. So there is another word, cardinality. Cardinality of a set. So cardinality of a set is actually nothing but the collection, is the number of element. Cardinality of a set is the number of
Element in set.
element in a set. Let's say it is generally denoted with the, you can say like this. This is the cardinality of a set, which is you can count the number of element in that set.
Sir,
So in this course, we generally cardinality word used for the finite set only. For infinite set, we are not going to deal with the infinite set. Like if you are thinking that whatever we just now wrote the set, this one, n belongs to the natural number. So what is going to be the cardinality of this set is infinite, fine. But whenever we do the question, we generally asked on the question when it is have a finite cardinality is a finite number, because the cardinality of this set is, you can say, infinite. Okay, so like, and for example, you can think, suppose we have A is equal to some, let's say 1, 2, 3, 4 elements, or let's say number of players of if you are thinking, let's say this is P, Q, R, S, T. This is a collection of some characters. So just so somebody's asked what is the cardinality. So cardinality is just count the number of elements. This is going to be 1, 2, 3, 4, 5. So number of element is just the cardinality of the set. Okay, somebody has question, I think. Want to say something? Okay. So now, whenever you have a set, so there is another thing.
Sir, can you repeat the cardinality thing, please, once again?
Cardinality. So cardinality is just the count the number of element in that set is called the cardinality of that set. Suppose you have this. Suppose you have a set, this one. So what is going to be the cardinality of this set is just count the number of elements. So
5
this is going
element.
to be 1, 2, 3, 4, 5. So there are 5 elements. So you can say the cardinality of that set A is actually 5. Sarfaraz Ahmed want to say something? You have seen on the
Yes, sir.
here.
Yes, sir.
Yeah.
Yes, sir. Sir, actually, I have one doubt in the part that you explained before
Okay.
this, the
Okay.
Venn diagram part. Sir,
Mhm.
actually, when we have questions like the question that was also given in the mock assignment, we have question like this there are this much student and this much percent like this thing.
Mhm.
Say for example, there A, B, and C. There are A, B, and C, and
Mhm.
A also like, B also like, and C also like. If
Mhm.
they both like, that is the intersection part. Okay.
Yeah.
And if it is given like either A like or B like, so we will treat them as union part.
Yes.
Am I correct?
Yes. Yes.
Sir, but what about the part that was given like none of them like? So what we will treat them in,
So in that
according
case,
to the formula?
none of them you will think that outside of this. So this is going to be the none of, because we are.
Please
Sir,
explain that question
can you
after
write
the
in
lecture.
an expression? No, actually, it is not the question. It's a general thing. Actually, sir, could you please write the expression of this that you just told about the square box and its complement of this? Can you write the expression of this?
So actually, suppose you have a set A and set B. Okay. Suppose you have a set A and set B. So suppose something like A is like the, let's say a collection of a student who is liking math, and B is the collection of a student who is liking science.
Okay.
So okay, so if both sets like this is, if you are taking the union, that means this is the number of a student who is liking both subject. Both
Okay,
means
okay.
sorry. This is the number of
Either this
students
or
who is
or this.
liking any one of the subject. If you are taking the union, that
Okay,
is means
yeah.
something he is liking. Like any one of surely he is
Yeah,
liking one of the set. Sorry, one of the subject. And
Okay.
this is the number where this is the number of student who's liking both subject.
This is the intersection. The both like the same thing.
Intersection, both
Yeah, yeah.
subject. And if we are thinking about none of the subject is liking, then it is going to be
Yeah.
surely out, because you are only thinking the, suppose now you can give in number, like suppose there are 100 student, okay, in that
Okay.
maths liking let's say 40, and science is liking let's say uh, 20 only. So
Okay.
in this case there are student are remain. See, there are 100 students. So if
40.
you count,
40 will remain.
so 40 will remain. No, still
but my-
see
actually-
still this number is going to be common. Some number going to be common. Let's say assuming to be x, then this number is
Okay.
going to be 20 minus x.
Okay.
In that case, you will say, okay, 20 minus x is going to be the, so the whole number is 40 plus 20 minus x is liking any one of the set. So, and 100 minus, why it is not working? 100 minus this number is none of the subject is liking.
Sir,
Like
if we talk
outside.
about the in the way of union, so we will call it 100 minus A union B. This is what I want to ask. Is it correct? Is it correct? 100 minus
None
A
of,
union B.
yeah, none of is liking means 100 minus
Okay,
just
okay.
outside. This is going to be outside, outside of this both circle.
Thank you, sir. Thank you. You can continue.
Sir,
sir.
sir.
My bad.
Yeah.
Sir, can you please take the questions from the mock?
Yes, sir.
On
So
the
please
on the
explain that
set operation.
Because
Hello, sir.
there is a lot of
question be
confusion,
last.
sir. Because I tried to I know this concept, but when I tried to solve this question, it was very confusing.
Yes, sir. That Venn diagram question, it is also
Yes,
confusing.
sir.
Please explain this concept more.
Sir,
Venn
let
diagram
revision
questions.
continue. Sir, you can
Yeah.
you can answer question later.
Yeah, let's quickly
Next
deal
question
with
number
this.
2.
I
I think.
This
next
is
question number 2, I
revision
think.
class, right? Not an answer.
Yeah, this is
question.
revision.
Yes,
class.
revision only. Yes, some as an example
Yeah,
for clearing the
actually,
concept.
I want to take a question. Yeah, let's finish one example on here. So this is, I think, not second question. This is the third question, I think. This
Yes,
one.
sir. Third question. So Venn diagram question.
So
Yes, sir.
so the question is for the purpose of research. There are 1,000 students on a survey of the 1,000 student is conducted. Okay, those student on which is on online degree, from online degree. The result shows 52 like CT, 42 the same as here is we just now discussed, 45 like statistics, 60 like mathematics. Okay, and in addition 25 like both CT and stat, and 28 like mathematics and statics, 30 like CT and mathematics, 6 like none of the subject is here. Based on this information, which of the following is going to be? There are three questions, sub questions are here. How many students like all three subjects? Okay, so, and the second question is find the number of students who like only one of the three subject. So we'll quickly finish this. As solution is here, let me explain here properly. This is the solution is already available of the mock. So as information is given, 52 like CT, okay, and 45 like statics, and mathematics is 60. So you can think on the Venn diagram. Okay, here is, let's say, let me create it. Let me create here. So there are three subjects: math, CT, and statistics. So as here it is saying 52, 45. CT is 52. So CT is 52. So this is includes this whole. So this is going to be 52, and statistics is 45. So this is the whole, like including the CT and maths is also will come. So this is 45%. And mathematics is 60%. So this is the whole. Will include the statistics and CT also. So this is going to be 60%. I'm erasing this. Okay, let me say percent thing. Okay, now CT and stat, the information statistics also given that 25%. So now the numbers become CT and static. This number is going to be 25. Now is specified here. Okay. And statics and mathematics is 28%. So this number, this thing is 28%. And CT and mathematics is 30%. Now here, this is math and, sorry, math, CT and, sorry, here is, I made stat and math is 28%. This is not stat and math. This is stat and math. This is 28%. CT and mathematics is, am I audible right now?
Yes, sir.
Okay.
Audible.
Okay. So this is going to be 30%. So here is, see that here is common number of a student is coming. So the first question is asked here, how many students liking all three subjects? So let's say now the extra information is 6% is like none of the given subject. Means you have 100%, in that 6% is not liking any of them. That means, as here, this example we just now discussed, this is 100. This box is collection of a student, you can say. And in that 6 is liking none of them. Means if you remove 100 minus 6, which is going to be 94%. So 94% is actually including only 94% now you can say in this, surely from in this. And 6% is actually outside. These are going to be the 6%. Outside is 6%. So you can remove 6%. So 94 is actually, surely if you are taking the 94 and from the 100 student, 94 students surely taking any one of the subject, at least any one of the subject. So 94 is nothing but the union of this, you can say, math, union, CT, union, stat. This is the 94. Then you can finally, you can see that number of stat, math, and any one of the surely the student is taken from 94 student. Now, as now I hope one by you can take it out, right? You can use the formula from this one. Otherwise, you
Yes,
can
sir, yes,
assume
sir.
here. Okay. Now I hope it is clear. Making now it is easy. Like you can assume from here this is X. The all three subject you can think the number of student is X here. So once you assume this is X, so this number is only this number. This number is going to be 30 minus X, because as the whole is 30. So if you remove this one, this is going to be 30 minus X. This whole is actually 28. So only this portion is going to be, as here the whole is 28. So 28 minus X. Similarly, the whole is actually 25 here. So only this portion is going to be 25 minus X. Okay. Now, separately you have counted this portion, this portion, this portion, and this portion. Separately you have counted here. Now back to here. This whole thing is 60. Separately you have already counted this one, and this one. So what is going to be this portion now? So the whole thing is 60. So only this portion is going to be 60 minus. Just count this one, and this one. So this one is going to be 28 minus X plus this portion is X and this portion is 30 minus X. Now this is going to be the number of this portion. This portion is going to be this one. Separately this one. And now you can count separately. And what you can do, let's say you count it separately. This is, let's say this is alpha, and separately you counted this is beta, and already you have separately counted this one. So what you can do, just add those all. Let's say alpha plus beta plus this one plus this one. Now add this one, this one, this one, this one, separately add all, and this is actually 94. So without going to be the formula, as here this formula is written, without going to be this formula, separately you can do from this picture. And now you have only one variable, x is here, and now you can solve for x. Is it clear to all of you?
Yes, sir. Thank you,
Yes,
sir.
sir. Yes, sir. Thank you.
Yes, sir.
Yes,
Thank you,
sir, clear.
Okay. Now let's move on the relation. This is the enough thing on the set operation. Deal with the operation, set operation. Now the relation, there is, whenever you have set, somebody have want to say something on this here, have doubt, Ashish or Kajal, I think.
Sir, if you explain this with the set relation formula, that might be easy for calculation.
So here it is clear, right? As we took the set operation and with the example.
Sir, you can
No,
solve it
no, what?
in last week. We should proceed for revision.
Yeah, doubt, we'll take the doubt. I took this one because of already we discussed the set operation. So I want one question on this. That it that like this one is makes more clear when what is the union, what is complement, what is all these are in this question have included. That's why I took this example. Let's move on the relation now. So whenever you, so relation, the term, the simple definition of relation is just nothing but, if you are defining, suppose you have a set yes, and you are talking about a relation on this set S. So relation is nothing but a subset of the Cartesian product of this set. So then what is the Cartesian product? So Cartesian product is nothing but a, suppose you have a set this one, okay? Let's say 1, 2, 3, only 3 element it have. So Cartesian product of this set is, just write, means, let's say, now you can think 1, 2, 3. So one by one you can take pair, like this is going to be 1, 1. Now this is 1, 2, 1, 3. So 1, 2, 1, 3. You can write the element in the pairwise. Similarly, now for 2, you can think 2, 1, 2, 2. 2, 2 and 2, 3.
And the last one will be 3, 1, 3, 2, 3, 3.
And the last one is 3, 1, 3, 1, 3, 2 and 3, 3. So writing the element in the pairwise is, you can say, the Cartesian product. So, or simply if you have two set, so Cartesian product you can say of two set A and B. So let's say A is some collection of some element and B is some collection of element. So taking the product of these two is the writing the, so here is order matters here. Order in means you can write the first coordinates at the from the first element. So in the simple definition, you can say, suppose this is xy, you are writing in the pairwise. So this is xy and this x is this X is from A and this Y is from B. This is the mean to say taking the product of it of two set A and B. So now the term is relation on a set. Okay, relation on a set is defined to be the you can say, let's say I'm saying that this is a relation on set S. That means I'm not defining any relation, just say a relation R. So R could be just subset of S cross X. Sorry, S cross S. It could be a subset of this Cartesian, whatever you have this one. So I'm defining, let's say this is this is the collection of this is the Cartesian product of the set X, sorry, set S. Now I'm defining, let's say R is actually now, let's say 1, 2, 1, 3, 2, 2. This is, so this is a subset of S cross S. So R is, now you can say R is a relation on set S, where define it is like this. I didn't give any property like generally we used to say the relation is a collection of family. You are defining a relation on a set collection of family member. You are defining a relation A is brother of B or sibling, like this. There are relation. So collection, let's say for example here we can take so let's say S is the collection of family member. Okay, collection of family member, and defining a relation on set S is as, so here is, whenever you will say, now that see that you will write like this, X, Y, so X and Y both belongs to the S, and or simply say, and let's say X is younger brother to B, or X and Y are brother to each, means brother will just say brother means will come the thing, or you can say younger brother is a younger brother to B, or Y, you can say younger, or simply say younger with respect to Y. So younger brother with respect to Y. So see, here is, we are defining some word, here is the relation, but here is just I just given the some element. Yeah, but you can see the elements are in the pairwise. So here you can say A is here is 1 is related to 2, 1 is related to 3, 2 is related to 2, like this. Like here you can say X is related to Y. The relation is given as X is younger brother. With respect, in comparison of Y, there are some 5, 4, 7, 8 brothers are there. Okay, so these are such kind of relation. Here is some word we used, but here is just given the element and pairwise. So this is a relation. So relation is nothing but just take the Cartesian product of that set and take any subset. This is suppose this is a set. Sorry, this is a relation on S. Another relation on the same set I am defining with the different collection of different element from this this set. Let's say here is 2, 3 and 3, 3. So this is another relation on the set, this on the same set. Yes, this is another relation. This is a relation, this is another relation. Yeah, you can say 2 is related to 3 now. R2 is here. Let's say here is, these are all R1. And here is 3 is related to 3. So differently. So relation is nothing but taking the subset of that Cartesian product. So that is going to be a relation. You can say.
Sir, I have a question.
Okay.
Is every Cartesian product will be in order pair?
Cartesian product in ordered pair.
It can be triplet also.
It's depend on like how you are taking the Cartesian product in the, like you are taking the 3 sets in multiplication or 2 sets in multiplication. That's depend on how you are taking. Your binary
Cartesian product will
multiplication
be
or tertiary.
pair of 3 or pair of 4?
Sorry. Okay, I don't know even. So there are some relations. Now once you know the relations, so there are some different kind of relation. Let's say symmetric, reflexive,
Sir,
and another is
So your voice
symmetric,
breaking.
reflexive, antisymmetric, and transitive. Yeah.
sir,
Okay, just a minute. Let me change my.
There is some network issue on your side, sir, I think.
Am I audible right now?
Yeah, for sure.
Yes, sir. Yes.
Yes, sir.
What you were breaking earlier.
Am I audible right now?
Yes, sir.
Yes, sir.
Yeah.
Okay. Okay. Now let's move on to the reflexive, symmetric, and transitive thing. So one by one we'll deal with the reflexive relation. Reflexive relation is simply say in the set form, if you consider. So suppose let's say in the pictorial form I'm saying. So suppose you have a set S and you are defining a relation on this set. R is a relation on this set S. So R is actually, R is going to be the element, whatever in the element will come as a pairwise. You will take, let's say, you will take S cross S, and you will take a subset that is going to be your relation. So it will come in a pairwise. Okay. So let's say this is a relation. So you can think like, see, I am writing like this. Now in pictorial form, we will see. So suppose you are able to write this set as this line, and this set is in the same line. The same set. Suppose this is the set S. So yes, sorry, already the see the different way. Like already the XY plane, right? X and Y. Where is this is going to be X and this is going to be Y. So what is X and X cross Y? Here is you are taking these are the element of this set. Like you are writing. So let's say 1, 2 you are writing. So 1, 2 is from X cross Y. So same thing you are writing here. So suppose this is the set here and this is the set here. So reflexive is actually nothing but you can think those elements.
So
like
diagonal element?
Yeah, diagonal element. This is going to be your reflexive elements. So whenever you are defining a relation on a set, so reflexive is how many element in the set S that would come. Like let's say S is actually A, B, and C only. So reflexive is you can think that A will be there, BB will be there, and CC will be there. If suppose there is another element D and you are missing this, so this relation is not going to be reflexive. You cannot call it this is reflexive. This is not reflexive. For each element, each element should be related to with if that relation is saying to be each element is related to itself, then you will say that relation is actually reflexive. So that means if you are saying this is going to be reflexive, then surely DD should be. You cannot miss this pair. So each element should be there with a pair with the same element. Means each element is related to itself. Then you can call it this relation is going to be reflexive.
Yes, sir.
Okay.
Understood.
Now,
Sir, I have a question on this.
Okay.
Is a relation reflexive only when the Cartesian product is taken on the set itself?
Then yeah, you can say this. Because you can, whenever you are thinking on different set, then how you are defining that relation is difficult. Yeah, if you are taking that, let's say A is actually 1, 2, 3, a collection of number, and B is actually this set. This will be is actually A, B, C. So now we are taking A cross B. So this is going to be 1A, 1B, 1C, and others will come. So how we will say now, now I'm taking a subset of A cross B. Let's say here 1A and 3B, 3B, only these two elements I am taking.
So we can randomly select any element to be a subset.
Sorry?
We can randomly select any elements to be a part of the subset.
Randomly select means what?
Like how you from here you took 1A and 3B, right? So
Yeah.
there was not any condition, right? You just took them randomly from the set.
No, it is not randomly. First we
No,
take
random.
element.
I took element and then I'm taking the A cross B, right? And now I'm taking some element. See, I'm defining relation now on let's say now the word is A, set A is related to set B, where it is in the relation the elements are like this 1A and 3B. Now this relation is not going to be reflexive, or how you will say that, because which one is going to be, so reflexive will come on. So you can say that reflexive when you see the definition of the reflexive relation. So see, whenever we going to deal with the reflexive, transitive, or any kind of, so please see the carefully the definition, how it is defining on the same set or different, or it can be work on different multiplication, or like it surely you need to see carefully the definition. The reflexive, when you see the definition of reflexive, surely on the same set, whenever you are talking about on the same set, that relation on defined, like then it will possible, right? Otherwise no.
Yeah, got it, sir. Yeah.
And now the term is symmetric. So symmetric could be, here is symmetric, you can define symmetric on here on this set, because
Excuse
now
me, sir.
1A is there, A1 could be there if you are thinking as a symmetric. Yeah.
Hello, sir. Let's say we have two sets. So set A is basically all the positive natural numbers. Set B is all the multiples of positive, multiples of 1. And then we take Cartesian product. So there will be ordered pairs that are reflexive.
Ordered pair that would be reflexive, okay, but how you are defining now your relation is like that set is now you are taking A as what is the set A?
Positive natural numbers.
Okay, positive natural number. Okay, let's say 1, 2, 3, 4. Okay.
B, set B is multiples of 1.
Multiples of 1. Means each natural number. What is multiples of 1? Now on the integers you are taking, or natural number you are taking, what's the multiple of 1?
Like
The
all the natural
real number
numbers
will
that are
come by
multiples of 1. Basically natural numbers. These are two different sets.
Okay, 0, 1 now will come the same thing.
They are the same set, no?
They are the same set. Now you are defining a relation on the same set. This is the same thing, right? So see, mean to say, okay, whatever the thing, mean to say, whenever you are defining reflexive, surely on the same set, you are taking the subset of the same Cartesian product.
Yes, sir. That is my question.
Now when we talk about the symmetric relation, so symmetric relation says whenever you have an element, let's say R is a relation on a set S, or you can differently say R is a relation, or differently you can say A is related to B. Now here symmetric word use, you can take the different set also, it will work, or the same set you can take. So R is a subset of A cross B. So, and let's say A and B an element of that relation, then B and A should also be there. Then you can say the relation is symmetric. Or now on the same set you are saying, so it will the same definition. Definition is the same. The relation, symmetric relation says nothing else. See, if you see the reflexive definition, it is saying on each element should be that each element, the each pair A, B, B, each element should be there. But here is nothing. These are not saying on the each element. Just says AB is there, then BA should be there. That's why it will work for the different set also. But here the reflexive work on only the same set. So this is the definition for symmetric. Now the transitive. Transitive is also you can think for the different two set. It will work for the different two different set. So see why these three symmetric, reflexive, symmetric, and and transitive. Why it is needed? Then these three, including these three, when a relation qualify these three relation, then you will say that relation is actually equivalence relation. And when there is a equivalence relation, then there is what is use of that equivalence relation? Why we are saying this relation is equivalence relation? Then actually use of the equivalence relation is you are thinking, suppose you have a set S and suppose R is a equivalence relation on this set yes, then equivalence relation make a partition on this element. So here is suppose an element A is there. So whatever the element A have property, so in this partition, all elements have the same property. Means these elements are reflexive. Means A will be there, B will be there, and symmetric means AB in there, BB is there. Like each partition means it will collect. You can collect. When partition means you can collect those elements. Like each element, this partition have the same property. This partition have the same property. This. That's the use of then you are able to say the reflexive. Whenever the same set will be there, then you are say this relation is going to be reflexive, symmetric, and transitive, and then equivalence word come and equivalence relation, partition, or you are able to do on the same set. If it is two different set, then there is no mean to say that relation is not going to be the reflexive itself. You can directly say that. So symmetric is work on the two different set. As similarly transitive is, let's say two term is there. If AB related, there are two condition is needed. If an element AB is there and
Excuse me, sir.
Sorry, yeah. BC is
Sir,
there.
I just have a small doubt in symmetric. Can I ask?
Yeah.
Yeah. So, sir, for a relation to be a symmetric relation, should all the pairs in the set obey the symmetric law? Or even if one pair doesn't obey, then it's also called.
Then it is not going to be symmetric.
Okay.
If
So
anyone is missing, if anyone is missing the symmetricity, all the pair, that means any one of the pair is missing the symmetricity. Let's say for each element you have, but only even a single pair which not obeying this condition. Let's say 3, 2 is there, but 2, 3 is not there. For all pair it is, but only for the single one it is not there. Okay, so then you can then you will say, okay, this one is not going to be your symmetric. Guru wants to say something on here.
And
Guru.
sir, if it is, sorry, sir, can I ask?
Yeah.
Sir, if it is like given just one reflexive kind of item, like 3, 3, So just 3, 3 will be a symmetric, right?
No, then still for each pair for means.
But for 3,
this
3,
all.
sir, it will be 3, 3 only, right? For symmetric.
First, first 3, 3 it is, yeah. If it is 3, 3, then yeah, it is
Just
a
3,
symmetric.
3. Yes, then
This
it
is
is
a symmetric.
Okay.
This is a symmetric because take the revert of it still will come the
It
3,
will
3.
be like this.
The
Okay.
same element.
Okay, sir.
So actually you can say our reflexive relation, you can say the symmetric also. Reflexive only just these element. So if you have a relation, only the reflexive, like only these elements are coming. So then you can say this is a symmetric also.
Then the identity set is the symmetric set also.
Identity?
Identity, the AA, BB, CC, this
Yeah.
is symmetric as well as reflexive.
This one is, yeah, this one is actually reflexive and symmetric both.
Okay.
Now the transitivity says if AB is there and BC is there. See, here is and where is there. If any one condition is missing, let's say first condition following the second condition is not there, then still you can say that relation is going to be transitive. For example, I am saying only this is the on a set, let's say yes is 1, 2, 3, and I am defining a relation which is 1, 2 and 2, 1. Okay, so suppose this is you have, and suppose you have this relation. So see that this relation is not reflexive, as it should be 1, 1, 2, 2, 3, 3 should be there. So this is not reflexive. Now check for the symmetricity. So 1, 2 is there. So yeah, 2, 1 is there. If 1, 2 is condition says 1, 2 is there, 2, 1 is there. So this relation, that's why going to be this symmetric. Now check for transitivity. So 1, 2 is there. Okay. So 1, 2 means here 1, 2. And okay, now the B part is 2. So 2 and oh yeah, I'm missing here this one. 1, 2 is here and B part is 2 here. So 2 and some C is there. C is okay. 2 is here. Yeah. 2 and 1 says. So C is working here 1. So this implies 1, 2 is there, 2, 1 is there. That means 1, 1 should be there. AC. So 1, 1 is there. No, 1, 1 is not here in this relation. Then this relation is not transitive. So this is not reflexive, not transitive, but yeah, symmetric. This relation is symmetric. Now let's say R is just only this one, 1, 2. So the same set and yeah.
Sir,
Yes.
if the transitivity is not getting checked, then it is said to be transitive, right? Like 1, 2, or the last number is not present in any either of the elements, then it is not getting checked, which means it is transitive. Is it like that?
Yeah, it is like the same as here it is. See that this is not reflexive as 1, 1, 2, 2, 3, 3 is not there. This is not symmetry because 1, 2 is there, but 2, 1 is not there. Now, but this is transitive. This is transitive relation. Why? Because it is following one condition. Yeah, it is not getting checked. Like the second condition is not there. 1, 2 is there. Okay, fine. And is there any element which checking with the 2 and something? 2 and something? There is nothing. So it says that, okay, fine. It is not following the second condition. Then you can say, okay, it is no need to check this, and this is going to be transitive. So this relation is actually transitive.
Got it, sir. So reflexive is similar to antisymmetry, you are saying?
Sorry?
Reflexive is similar to asymmetry.
Asymmetric.
Asymmetric. And symmetric is?
No, it's antisymmetric. Antisymmetric. AB is there, B is there, the antisymmetric. Or symmetric is AB is there, then B should be not there. That's the antisymmetric. Sorry, asymmetric. So those relations not taught in this course, so no need to talk. Antisymmetric is only there, I think. or symmetrics is not taught in this lecture. So I think that question will not ask in the qualifier you can see in the graded
Actually,
also.
sir,
but
in the previous
anti-symmetric
qualifier
questions ask
question,
again.
Anti-symmetric is there. So anti-symmetric relation is that if the anti-symmetric says if AB is there and see another as transitivity, the same thing, and you can say in the transitive and what is there. So AB is there and BA is there. This implies A equal to B. If it is happening, then it is anti-symmetric. Let's check for the whatever we have this relation. Okay. So what is this? This relation is anti-symmetric? No. Why? Because
anti-symmetric
1, 2 is there, okay, and 2A is there. Sorry, 1, 2 is there and 2A means AB is there and BA is there. And so these two, including these two, says A equal to B. So that means 1 equal to 2, but not 1 is not equal to 2. So this relation is not anti-symmetric. But here, let's back to this relation. 1, 2 is there, fine. 2, 1, there is nothing. This relation need not to check because one condition is falling, but not falling the another. BA is not there. The second and after the and. So that means 2, 1 is not there. That means you can say same falling as transitivity. This relation is actually anti-symmetric. Only one condition following. So it is no need to check the next as here. Then there is no 2, 1. So that's why this is going to be the anti-symmetric relation. Okay. As transitivity is happening. 1, 2 is there. 2 and some element. No, there is nothing. So then you can say this is transitivity. Similarly for anti-symmetric.
Sir, can I ask a question?
Okay.
The relation AA, BB, CC, is this relation is transitive too?
Yeah, it is going to be only if you are thinking yes is A, B, C. See, that's why it is needed A, B, C, and you are thinking relation as only AA, BB, and CC.
Yes.
This is BB and this is CC. So yeah, it is transitivity because this relation is transitive because AA is there and A and something is there. No. So transitive. BB is there. Okay. B something is there. No. So it is second condition. Always the second condition of the transitive relation is not there. So you can say, okay, this is transitive relation. This relation is transitivity. Transitive.
But sir, this will also be reflexive, right?
It is reflexive also. It is transitive also. It is anti-symmetric. Sorry. It is symmetric also.
Symmetric.
Okay.
It is symmetric also. So you can say this relation is an equivalence relation.
Identity also.
Sorry.
Identity.
Identity relation says A equal to A, right? A relation is when A equal to a relation is identity is the collection of A equal to A, right? That is what is the definition of identity relation?
Sir, it also contains a diagonal element.
Only the diagonal elements. So if you see the definition of identity, it is defined on the you can say on the numbers. What do you mean by the A equal to A? Or equal to is generally used for the number, you can say. So that's why I will say again the definition of a relation where that relation is defined. You cannot apply the OR relation on the on this identity relation, symmetric, anti-symmetric. You cannot apply on the any relation. See the carefully definition. Generally, identity is on the, you can say on number, because number have some equality. Okay, two numbers are equal or not. So it's needed now is, let's say S is actually 1, 2, 3, and on that you are defining R as 1, 1, 2, 2, or only 1, 1 is there. So how the definition of where you are defining that set, if it is following, then you can say that relation is identity or okay.
Okay, sir.
Be careful with the definition. Please see carefully the definition where that relation is defined, on which set. Is it on numbers? It is on the characters, or it is on the same set or different set. It is important. Now next move will let's move on the function. Main thing is function. Function is a specific relation. Function, in the simple definition, you can say function is a kind of specific relation. So what is the specific what is the property of that relation is? It says the simple definition is, as here, as we generally use the relation on a set A. Let's say set A is related to B. Okay, a set is related, a set A is related to set B. So is this relation is a function or not? The main thing is, so in generally you will say A cross B, where A, or generally A is related to B, means here this is going to be your domain and this is going to be your codomain. You generally say in the relation itself also. Okay, once you have this one, so in this relation, if you have writing, let's say this is 1 2, in this set is 1 2, and set B is, let's say, AB. Okay, and then A cross B is going to be 1A, 1B, and 2A and 2B. And I'm defining a different, let's say R1 is. So R1 is here 1A and 2B. Right? Yeah. And R2 is 1A and 1B. Okay. And R3 is, let's say, 1B, 1B and 2B. See, now we have three relation on the same, like see that this is a subset of A cross B. See that the relation is actually nothing but a subset of the Cartesian product, you can say. So this is also subset of, this is also subset of A cross B. Now we have three different relation. Now function says, what is the definition of function? Function is a specific kind of relation. So what is the specificity is? Here is, see that this is domain, this is codomain. So each element of each domain. So there are two property, you can say. Each element of domain have image, first thing, and second thing is it have unique image. So see that here, okay, and okay, okay. So each element have unique image. So let's take what is the definition. The first says each element have image. So of the domain, each element of the domain have image. So a element of the domain is 1 and 2. Okay. Now have image. This image means here, image means had surely have related to. Here is relation, you can say. In the codomain, you can say the codomain is actually map, element, or image. The second pair is going to be the image of the first pair. Sorry, second pair of the element is going to be the image of the first element, that is here in this x on the first, you can say the first element. Here is, you can say this is first element. Let's say this is second element. So or first coordinate generally, first coordinate of the first coordinate. The second coordinate is actually the image of the first coordinate. So yeah, okay, one have image A, okay, 2 have image B. So yeah, one condition follows, each element have image. The second condition says have unique image. So okay, here it is happening. See that B is different and sorry, A is different and B is different. So each element, for one element have unique element, for two element have unique element. So this is actually a function. It follows a function. It follows the definition of function. So R1 is actually a function. Let's move to the second element. So
Yeah.
second relation.
Can
Yeah.
you please explain that again? I did not get it.
So function have two definition, two condition. Function is nothing but a relation, but it have two condition. First says each element have image. So here is, let's say, as here each element have of the domain have image. So this is domain have 1, 2. Okay. So for one element have image A. Yeah. For second element, this is 2. For the second element, here is have image B. So yeah, this is follows the first condition. Second condition says have unique image. Image should be there, have unique also. So yeah, A is unique and B is unique. So that means it follows the definition of function. So relation R1 is actually a function. Let's see the R2, this relation. So see that this is 1, 2 is the domain. 1 is here, okay, image have, and 1 have 2 images. See that for single element, each have 2 different images. So that means you have set A, and let's say this is B, this is 1, 2, and this is AB. So the R2 is actually this one and this one. See that 2 images for a single element of the domain. So in that case, this is not function. It have unique, it should be unique. So this is your F1. Sorry, this is R1. Sorry, this is R2. This relation is actually R2. And our R1 is this one, 1, 2, AB. So this is our R1. Now let's move on to R3. This is 1, 2, this is A and B. A and B. So R2 says 1B. Okay, 1B, and this is 2B. 2B. Okay. So see that the first condition says each element have image. Yeah, 1 have image, 2 have image. Okay. Each element have unique image. So 1 have B image, 2 have B image. So it have actually unique image. It is following the same condition. It is mapping to the same element, but it have the unique image. 2 have B element, 1 have unique. It is not happening to have this one, 2 images. No, it is following the only one. So actually R3 is a function also. So this is a function. Now let me take the another R4, which is only 1A. I am taking a relation R4. So let's say now here is R4. So 1, 2, and AB. So the definition of the function is says each element have image. So okay. So this is R4 our. Only this is our R4. Where is the image of the second element? The definition says each element have image. So for the second element 2 here, there is no image. So again, R4 is not a map. So this is not a function. So see that I made it 4 condition, different condition on checking of the definition of. So then you can say a relation is a function. When you will say a relation is a function, it follows 2 condition. Each element of the domain have image, and it have a unique image. Not only the anyone. Both conditions should satisfy, then that relation is actually a function. That is the function here.
Sir, in relation R3, how is the image unique, sir? Because first element also has the same image, and second element also.
Can you compare R2 and R3? Then you can think that what is happening for R2 and R3. One have 2 different images. It have not unique. A is also image, B is also unique. Uniqueness means in this sense. Uniqueness means in this sense.
So I think basically it is the element of domain should just have one image, right?
One image only. It doesn't have 2 images. Here is happening 1 image. See that it is only 1 image. But here it have 2 images. 1, 2 means A and B. So uniqueness in the image means this is the mean. You can think the difference. You can see the differences in this sense. Mean to say.
You mean between R2 and R3, right?
Yeah, you just compare R2 and 3, what you are looking the differences here.
Okay, got it. Thank you.
Okay. This is the mean to of uniqueness of the image. Okay, this is all about the function. That's all the function. Now you can generalize. See, we are specific, we are on the fixed element like finite on, we are talking that this relation, this function on the finite says. Now you say the broader case is fx is equal to x square plus 3x plus 2. This is a function on R. X is belong to R. Yeah, this is following the same condition. This is the same definition if you check that. So see that what is happening here. Fx is a relation. Fx is a relation. How it is a relation? So see, if you think this is a relation, how it look like the relation? This is actually nothing but the x square plus 3x plus 2. This is going to be your, okay, let me erase it. So R is actually my pen is, just a minute. Here is R is actually this one, where X belongs to R. So this is a subset of R plus R. This is our relation here. So if you see that this relation actually follows the condition uniqueness and each element have image. So see that what is happening. If you take any real number, it have image, this one. The second or the first condition. The second condition, it have unique image. So see that if you take A, okay. So A means now you take the image. So this is going to be A square plus 3A plus 2. So this is a unique image. It is not going to be the different. You cannot find, if you are taking A as, it is not mapped to the different number also. It is only this number. So actually this follows a condition of the function. That's why this is a function, this relation. From the function you back to the relation. So this is a relation. So this is actually, this relation is a function. Or back to here, this in this function in the relation form, you can see it like this. Okay. So in the broader case is the same definition. Generally now the quadratic, we have seen quadratic polynomial, quadratic functions, polynomial function, exponential, different sine, cos, trigonometric function, following the same definition. Okay. Now,
Actually, could you please help
yeah.
me with what is ordered pair?
Order pair means here you are following the condition like if you are A and B. So order pair means this one. This one is from only A and this element is only from B. You cannot think, you are not right like Y and X. If you are following this A cross B, that's the mean to be order pair.
Okay.
Excuse me, sir.
Yeah.
So can you please give a similar example of an equation that is not a function, like you just did, that is a function?
Yeah, you can, there are many, like you can, now you can make a relation, right? Let's move on to the, like I just given the definition. Let's move on to the one and on to, then we will straight line. Otherwise I will give example. You can find like, now you
And
can
this is like
create R5.
y square equal to 4ax.
We can
Yeah,
take
okay.
the example
Y
of
square equal to 4ax.
You can think this relation.
Equation of circle, sir.
Equation of circle, x square plus y square. Okay, let's
Equals
say this one. X, y, this is a relation. Okay. The relation is like this. See that this is a subset of R cross R. So is this relation a function? No, it is not a relation. It is, this relation is not a function. The relation is in this form. This is the relation here, and this is the order pair. Okay. Oh, let's move on to the definition of 1, 1 and onto. So 1, 1 and onto. The definition of 1, 1 is nothing but in the pictorial form you can see. Let's say 1, 2, 3, and this is A, B. Okay. So 1, 1, let's say this is A, C also. So 1, 1 says each, like whenever you have, this is the case here for 1, 1. A, B, and this is C. For each element, for each element you have unique image. Okay, fine. Unique image is fine. And the definition, proper definition in the, what is the wording definition of 1, 1?
If X
Every domain element.
Every domain has unique
has a
element in
image.
codomain.
Yeah, that is the wording of the definition. Every element of the domain, codomain, or every element of the domain have unique image in the codomain.
If each
Not
element in set X is mapped to a distinct element in set Y, then the function is called injective function or one-to-one function.
In the pictorial form you can say, or the mathematical form, or the mathematical form, the definition you can say like this. This is the follows, like
every element of X have distinct element of in Y.
Yeah, in the codomain. In the codomain, like each element have, so each element have distinct images. It is the not case here. You can think like this. Let me create the, this is 1, 2, 3, and this is A, B, C. So this will not the case like this. So like each element, you have one element in the domain is 1 and 2. See that it have image is A also, and 2 have image also A. So in this case, this is not 1, 1. So you can say this is 1A and this is 2A. And the relation in the relation form, you can think this one. So this is a relation, as this is, and if in the set form you can this is a function. This function is not 1, 1. But here is the case is 1A. This is 1C, and this is 2A, and this is 3B. So see that each element of the domain, okay, each element of the domain and have unique image here. Okay, only one unique, each element of the codomain, there is a unique pre-image. You can differently say also. Each element of the not codomain, which you can say the image have unique pre-image, you can differently say. Image of the codomain, whatever the collection of images, okay, it have unique pre-image. This is the not as here. So this is, see that this is an element of the codomain. So this have not unique pre-image. See that A have two pre-images, 1 and 2 also. So this is the not case for 1, 1. And the another thing is onto. So onto says, here you can see that. See. So onto is, so this function is onto. For each image, the definition for onto is, for each element of the codomain have pre-image. So as here, there are 3 elements and each element have pre-image. So see that C have pre-image 1, A have pre-image 2, and B have pre-image 3. But this function is not onto, as C is an element of the codomain, but for this C element, there is no pre-image. There is no pre-image which have the image as C. So this is not onto.
We can
range
also
is the codomain.
Yes,
Sorry?
we can also say that range is, if the range and codomain is same, then the function is onto.
Yeah, and differently not onto. And differently, you can say in the range, there is another word is, range and codomain. So what is range? Range is actually the collection of image, and codomain is actually just element of how you are taking the mapping. There are two differences. Suppose you are defining, suppose F is a map from set A to B. So actually A is domain here and B is codomain, and range is actually this one. Codomain, this is domain, and range is actually FA. A belongs to A. Means collection of images. Range is nothing but the collection of images. And the case is when the range is equal to codomain, then you can say this is onto. As here, what is going to be your range for this function? Range is actually A and B. And codomain is your A, B, and C. So see the case, range is only AB and codomain is ABC. That's why this range is not, in this case, range is not equal to codomain. That's why it is not onto. Otherwise, for this case, see the range is actually ABC and codomain is also ABC. That's why it is onto.
Sir,
Two different ways.
sir, just a quick question. Do you mean
Okay.
that so do you mean that for range, every image must have a pre-image? Only
Yeah,
then.
for every image.
Okay. And codomain is even if we don't have
For
a
every image, not. The word is for every element of the codomain have
a pre-image. Yeah. Okay. Got it. Codomain are just the elements.
Codomains is just the elements as here.
So codomains have to have a preimage, so that means.
Okay. So for onto to happen, we need the codomain and the range to be equal. That means every element.
Equal.
Yeah. Okay. Got it, sir. Okay. Yeah.
As here is happening, range is actually the images, collection of images, and the codomain is actually the set, whole set as you are defining. This is set A and this is B. You are defining this function is from A set to B. Okay. So I actually mean to say some codomain has extra elements. You can say and extra elements different from images also. Okay.
Yeah. Got it.
Now let's move to
A question regarding the same. I'm not able to differentiate between onto and 1-1. So I'm confused now between 1-1 and onto.
Onto clear onto? Onto
Yes.
is clear?
Yes.
Okay. So what is 1-1? What is the problem now here? 1-1. 1-1 have say 1-1 says for each element here, if you take the each element here, the codomain, it map to the only.
Sir, your voice is breaking.
Okay, let me check once. Is it clear now?
Yes, sir.
Okay. And 1-1 says, okay, let me show you the case here. As it is very clear with the picture here, as I made the picture. Let me make it again, I think.
No, that is clear, but the problem is I'm getting confused. I'm finding it one.
What is the confusion now?
1-1 and onto, I'm finding it very much similar. So I'm not able to differentiate between them. I find both the functions are very much similar to each other. There is no difference.
No,
Sir,
here is the difference, right?
Sir, maybe. Sir, maybe in the
anyone can,
codomain, sir, in the codomain, you increase the ABC. Maybe you can take D and E also. Then it will be easy to understand for them.
Sir, would you mind?
In 1-to-1 function, fx is
that
equal
would be
to
good.
fy. Basically,
Okay,
x
so-
is equal to y.
Sir, with your permission, can I explain?
No, I think if sir will give another example
Okay.
with more elements, it will
let
be
me,
easy for me to understand.
Okay, let me try to give you a different perspective. Now, just assume, not assume, function has two different sets. In this case, what we are studying, set A and
Yeah.
set B. Now,
Yeah.
set A is considered the first on the left hand side, whatever you draw as a circle, as sir has drawn set A, 1, 2, 3, that is a set of domain. And the other one is set of codomain.
Yeah.
Important here is whenever you talk of one-to-one function, by name it is very much clear. We talk from the domain's perspective, that you don't have to think about codomain, just think about the domain. That in more simpler way, आप ऐसे समझो कि जो A वाला जो घर है ना, इसमें जितने लोग हैं 3, इसमें तीनों का ना कोई रिलेटिव सेट B में होना चाहिए. There has to be. अगर ऐसा
Yes.
हुआ और एक का एक के साथ ही संबंध होना चाहिए.
केवल
मतलब
एक का एक के साथ.
यस, 1 का A के साथ है, 2 का C के साथ है, 3 का D के साथ है, तो हर एक का एक के साथ है. किसके साथ है ये रिलेवेंट नहीं है. That is 1-1. Forget about codomain. Just think about domain. So whenever we talk,
they
of
should be different, right? I mean,
yes,
those
element
should be
can-
different. Yeah, that's the one
Yes,
thing
I-
missing is
I
from
did
function. Those
mention-
are different.
yes, I did mention कि every image has to be different. This is what I mentioned. अगर आपने ऐसा कर दिया इसमें, अगर इसमें दोनों बातें मैं और क्लियर कर देता हूं. अगर ऐसा हो कि 1 का A के साथ भी रिलेशन बन जाए और 1 का किसी और के साथ भी रिलेशन बन जाए, तो ये फंक्शन नहीं है. एकदम सिंपल है, ये फंक्शन नहीं है. फंक्शन नहीं होने के एक पैरामीटर अभी मैंने आपको बताया कि अगर
complete
एक
different image of every
Yes.
element in domain.
डोमेन का एक एलिमेंट का कोडोमेन का एक एलिमेंट के साथ अगर इमेज बनेगा, सो दैट इज perfectly fine, and those type of functions are we consider those to be one function. So
And
are you
अगर
clear
B
with
में
that, sir?
code sorry.
Yeah. I
code-
want to let me explain. You just started explaining from starting. So with an example, this one, I think it will make more clear him. Like, see that this example. So see, if you take this relation, this is 1A and this is 2D and 3B. Okay. And
I think I understood. I think
this
the
is
domain,
yeah. So
The
see that
domain-
each element have unique is this image, 2 have this image, 3 have this image. So this map is 1-1, but not onto. So if you think that this is 1-1.
because there is an empty element in codomain, that's the reason it's not onto. It's
Not onto.
Yeah. And same vice versa, if every element in codomain is associated with any of the domain element
Yes.
with
अगर
their individual image.
सर यहाँ पे ये इम्पोर्टेंट है मेरे लिए कि कोडोमेन के जितने एलिमेंट्स हैं सबका एक ना एक रिश्तेदार सेट ए में होना चाहिए. अगर
Same
एक भी
onto
एग्जैक्टली ऐसा जैसे 1 में, लेकिन 1-1 में बस हमारे पास एक constraint था. We were having some constraints, and the constraints are like we have to have one connecting with one, whereas when we talk of onto, we are not considering whether it is connecting with 2 or 1 or whatever. We can decide later on, but every element of codomain has to have some connection with the set of element of the set of A. आसान भाषा में अगर हम सेट ऑफ कोडोमेन के एलिमेंट्स को देखें तो सबका कोई ना कोई प्री इमेज, जिसको आप मोर टेक्निकल कहते हैं, आसान भाषा में सबका कोई ना कोई रिलेटिव सेट ए में होना चाहिए. अगर ऐसा होगा वैसे सेट को हम लोग कोडोमेन कह देंगे, सॉरी ऑनटू कह देंगे. सॉरी.
Onto, yeah, got it. Thank you,
Okay.
Ramji. Thank you. Thank you,
Okay,
sir.
let me quickly move on to the
Next topic.
next. That's enough for. Okay. That is on week 2. Let's move on to week 2. I more spent our time on. So week 2 we'll quickly finish that because there is no much technical thing, only just straightforward. It will not take time for week 2. That's why I spent it out time on week 1 because it have more things, relation, sets, function, 1 and 2. Week 2 is week 2 is the collection like studying on the straight line, and I hope all of you know that week 2 is not much tough because as now what do you mean by straight line is actually the same thing here is also happening, is one kind of relation. Whenever you talk about the straight line, when you come to the week 2, so or a straight line, so again the word is Cartesian product, and here generally the Cartesian product is we take it from R cross R. Okay. When we talk about the straight line, its usage purely real lines. Without that, it is difficult. So actually, on this Cartesian product is here. The Cartesian, you are taking the Cartesian products in between is on the real line itself, and the straight line is nothing but is one kind of, you can think of, you can say, if I'm making a function kind of. So a straight line is actually is one kind of function. If you see that, mean to say straight line is, so this line is R, this line is R. Generally this horizontal line we say x-axis, and vertical line will generally say y-axis. Okay. And a straight line is actually for you can say let's say this is suppose this is A here, and let's say this is whatever you are taking. Let's say the point is here. If when I take AB here, so this is AB. So if this is here AB, this is going to be A, and this is going to be B. Okay. So you are taking so a straight line is nothing but, you can in the set form, if you see that, so if you write, it is like this only. AB both belongs to R. That's all, I hope. Okay. Here you are taking, so straight is like, straight line is you are taking the points in this format, will form a line on a line. Okay. Not much spending on the proper definition is I forgot, I think. Okay, this is you can think, you can collecting the collection of the point which is form a straight line, the same, that wording, the definition the same. Straight line is, you can say this one. Okay, straight line is actually the subset, the collection of point, where collection of points of the, this is a subset, not exactly subset.
So we can say like a collection of points which follow a linear function is a straight line. Right?
Actually, straight line is nothing but a function. No? So generally we used to, let's say, so that's why there are different kinds of representation of the straight line, like slope form, 2-point form, general form. So, or generally, okay, with the equation or more mathematically, go if we more mathematically, so representation in the mathematically is ax plus by plus c equal to 0. This represent a line in Cartesian product if you are representing it. So actually this is a equation of a line generally. So okay, this equation represent a, so more mathematically is this one. Actually this is a straight line. So now you can match with the point wise, like y is equal to, now you can change is a by b x plus c, sorry, minus c, I think here both minus will come, minus c, a by b minus c by b, also c by b. Now you can take the point here is, you will give here, you will take some values from the x coordinate, you will take the values from it will give a y coordinate. So if you now draw the if you matching with the point for each, like here is, you can take x is equal to some number, it will give y. So if you suppose this point you got, this point you got, you like this, you got the point. If you draw that, if you match those points, you will get a straight line. This is, you can say, it's a straight line. And this is generally, you will say, a linear function, you can say in this different word. If you are thinking x as a variable, y as a variable, so you can see that each variable have degree 1. So such kind of equation, you can say, represent a straight line. And now once you know straight line as here. So there are different type form, like slow form. Let me see with the lecture, that would be good.
Sir,
Now
you can watch the summary of given in the supplementary contents also.
okay, let me go with that. Okay, for me it's not needed. Okay, so now once you have the sorry, what is here, rectangular coordinate system. Okay, so rectangular coordinate system, as here you can say, the taking the cross product of R class, you can say. So suppose you have a point here and a point here. Let's say this is x1 y1, other point is x2 y2. So you can find the distance in between these 2 points, and here is just a formula. If you see the, you want to find the derivation, what is going to be the distance between these 2 points here. So if you see the derivation in the video, it is given that how it is calculated. Okay, so that is from a rectangle, it is from a right angle triangle. Okay, and then calculate, this is going to be your, so this is x1 and this is x2. So this distance is going to be x2 minus x1. So if you map to here, this is going to be x2 minus x1, and similarly this is going to be y2 minus y1. So this distance you can calculate using Pythagoras theorem, you know, in the right angle triangle, a square plus b square. So this length is actually nothing but, now actually this line, this distance is going to be the x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance. Let's say this is t here. So d is actually this one. This is the formula, just formula finding the distance between 2 points. Now, for example, if you will say you can find the distance between 1, 2 and 3, 4. Suppose you have 2 points, let's say A, and this is point B, and distance between these 2 points is just take the differences of the x coordinate and square them. That is 3 minus 1 whole square, and differences between the y coordinate and square them. So this is 4 minus 2, and add them and take the square root of it. This is going to be your distance between the point A and B. Next thing is section formula is there. What do you mean by this section formula or section doing the section of? So for that you needed a line segment. So again, if you have those 2 lines A and B, okay, and suppose there is a point C. So suppose this is x1 y1 and this is x2 y2. Okay, and suppose there is a point, this is a line segment, and suppose there is a point on the line A and B, on the line segment A and B. So suppose this portion is some distance, let's say d1, and this portion is some distance d2. Okay, so suppose this ratio is given, d1 by d2 is given. So okay, so what is going to be your coordinate here? So anyone can unmute yourself and tell that what is in that case is your formula.
Sir, is okay.
We can divide it into m ratio n. Then we will multiply m to the x2 and y2. If we want to get x part, we should multiply m into x2.
Yeah,
And
so to find the x coordinate, just take this portion and multiply with this. Then what is that?
m into
x2 plus n into x2 divided by m plus n.
Yeah. So in
m
this case,
into
suppose here
x2
if you think this is
plus
m by n. So in the case main formula, we generally remember that m by n. sorry, so this is Mn. So M1, or let's say M1, M2, or let's say this is M1 and this is M2. So in that case, easy to remember that this is M1 X2, M1 X2 plus M2 X1 upon M1 plus M2. Let's say this is M1 and this is M2. In that case, X coordinate is this one and Y coordinate is with the same M1 Y2 plus M2 Y1 upon. Just take the ratio, add the ratio and separately do with the whatever the given points you have. And this is going to be, if you want to find that point, what is the coordinate of this point? So this is formula. Okay.
And we are doing this for the internal bisection, right, sir?
Yeah, this is for the internal bisection.
If it is
So
for
no,
external,
yeah. Yeah, and for the outer, I think for the outer section is, I don't think,
should-
sorry,
we
this
just
is in
minus
the
it.
lecture.
It
Is
is
it in the
given
lecture?
No,
it is
no.
Yes, sir, it is in the lecture, sir. I think it's in the book supplementary content.
yes.
Okay.
Not in the lecture, right? In the
And
video.
not in the video, I guess, but it's in the supplementary section.
So I have
So
a
and
doubt.
the outer section is not going to ask, I think only this section formula is only. It is
But-
that
Okay, sir.
outer section is not going to ask because it is not in the video lecture. Yeah, for the information it is in the book, but it is not going to ask for this
Oh, okay, sir.
qualifier in the quiz or in the graded assignment.
Sir,
Okay, yeah.
yeah. If suppose I get the ratio as 0, okay, because I solved one question and got that ratio. So
Mhm.
should the option that the point bisects the line externally, because I had an option there that the origin bisects the line externally in one of my activity questions. So then should we go with the external formula also in order to
No.
get the correct answer?
No, what do you mean by this external by like doing the section to the externally means what? You are
External-
thinking,
Yeah,
suppose
like
you have point A and B and you are thinking the point C here
yes,
and you are taking the ratio is like this.
yeah,
This
right.
ratio, this bigger one and this is smaller one. This is the mean to say external section. You can say.
Bisect.
Yes.
Yeah,
so-
it is doing to the out. Let's say this is T, or let's say this is M1 and this is M2,
M2. Yeah.
the smaller one.
Yeah. So
In
suppose,
that case, it's needed only the doing thinking of the outer.
yeah, so
section.
then we have to do it, right? Because by internal we are getting a 0 as the ratio.
So internal ratio is 0 means this one is going to be 0. M1 is going to be 0. That means that point is actually here. Any one of the point is.
Right. So it was given that identify whether the point lies on the line or not. Okay. So I got the
Correct.
ratio 0. So does that mean that the point lies on the line or is it external?
Yeah, if it is 1:0 means, see, whenever you, yeah, that line, yeah, whenever talk about the section means it's purely on the line. First thing is on the line, then you will talk about the, if it is here, how you will talk about the section, how it is doing the section.
So it
What
is
you talk about the section means surely on the line, then you are talking about the section. If it is outer or inner, it's depend or not, it is outer or inner, but it's surely on the line. Then you will talk about the section.
okay. Got
Okay.
it. Yeah.
Okay. Now next thing is area of a triangle. These are just formula. So I will just write the formula only. So if you have a I will write both formula and we'll see. I think in the solve with the assignment we did. So suppose you have A, B, and C, and you have suppose this is x1, y1, and this is x2, y2. So what formula? What is the formula of the area of triangle for this one?
Half of
1
x1
by 2
Yeah, mod x1
mod x
bracket
into y2 minus
x1
y3
y3 plus
y2 minus
right?
y3
yeah
plus x2
this is x2
plus
y3
x2 into
minus y1
y1
and this is, yeah, and this is
X.
and this is going to be your
Sir, your voice is
3
breaking again.
and then y. Again, okay, let's take once.
So you lagging.
Okay. Is it clear now?
Yes, sir.
Okay. So this is the formula of the area of triangle, right? X1, Y2 minus Y3. So in the anti-clockwise direction mean to say, sir, is you just write this formula in this fashion. This is the mean to say, like if you are assuming this is X1, Y1. So next is X2, Y2, you will take this one, and X3, Y3 will take in this fashion and write this formula in this fashion and take the mod of whatever you are getting the number once you write the expression and half of the white is area taking the mod of it because you need the area as a positive number only. So that's why you can take the mod and take the half of it. That is going to be the area of this triangle. And another way to finding the area of triangle, I am just giving it here. This is not in the lecture, I think, but yeah, the formula is 1/2, and this is generally say the height into this base. This is going to be, let's say, suppose this is t here. So, and base is, you can say, base. So this is AD 1/2. So if you suppose you are able to calculate using the section formula or bisection or whatever you have, anyhow you are able to calculate this coordinate of this D, then you can calculate the distance AD and you can calculate the distance BC. Okay. And take the product of it and take this half of the AD and BC, that is going to be the area of this triangle. But it is not always the case here. Is if you are taking the perpendicular height between these two, so D is not easy to exactly find the coordinate, but many time it is already given that okay, the points are, the lie sides are equal, or some extra information surely will be given so that you are able to calculate the coordinate of D and find the distances. Otherwise this formula is enough to do that. And the next thing is now the slope of a line. Now these are in the coordinate system only, finding the distance, finding the section formula. Now slope of a line. So line is,
Steepness of
relation
line.
between x and y, between the variables x and y. So so suppose this is a line, okay, this is a line in the coordinate system, and whatever the angle this line is making with the x-axis with the anti-clockwise direction, you will calculate this angle in the anti-clockwise, not this angle. This angle you will calculate. So just take, so what do you mean to say? Just take a point from the x-axis, say make a circle where it is intersecting, that is how much this angle is making. This is your this, if you take, suppose this angle is alpha, then take the tan alpha, value of the tan of the that angle is going to be the slope of the line, how much it is tilted. Okay, this is going to be your slope of a line. So generally if you have equation, suppose equation is given, suppose a line, equation of line is given, let's say 2x plus 3y plus 1 is equal to 0. So I just from the line I have started, no, sorry, I need to give the formula. Suppose you have a line segment, okay, A and B. So what is going to be the slope of this of a line which pass through these point? Okay, so in that case, Suppose this is x1, y1, and this is x2, y2. Okay. So slope of this line, where the line segment is AB. So slope of this line is going to be your y2 minus y1 upon x2 minus y1. So this is generally, this is the formula. Otherwise, the same as just now I was talked about this one. So actually, this is the same thing. This is the line. Suppose on this line, you have 2 point you are able to calculate. So x1, y1 and x2, y2. Okay. If you calculate with the same here, this formula, you will find the same. M is actually, you can differently say this is y2 minus y1 on x2 minus x1. If you have angle, then you can directly find. Otherwise, just take 2 points from the line and do this one. You can find the slope of the line. This is the formula. And how it got? By making this, if you see the derivation of in the video lecture, you can again, this is right angle triangle, and just calculate. So we want to find this angle alpha. So here, if you see the comparison in the videos are made, here is alpha, then this is the same alpha will come here. And how you will get that this alpha, this is right angle triangle. So if you see in video, it is very slowly have explained how this slope is come and how we'll get the formula. So formula
Yes,
is this
sir.
one.
Yes, sir.
Now, once you know the formula, this is all about now the lines, slope of a line. So this is the process to get the slope of a line. And now the next thing is parallel line. So whenever you have a line, okay, so there is another line. Suppose there is another line. So there is two possibility. So there is that is called, okay, any two lines, either they will intersect or they will parallel. So if there is a two line in a coordinate system, then there is so there is only two possibility can happen. Either they will intersect or they will be parallel. So what do you mean by parallel means? So suppose this is a coordinate system. So parallel means whenever you calculate the slope, suppose, or suppose this makes alpha with the x-axis. So whatever the
The
angle
slope of
this line is
both
making,
lines should be same.
yes, yeah, either either you calculate the angle, whatever the angle, by making this line and this line, these two lines have the same angle, or differently you can say, if you calculate the slope of this line, okay, suppose this is a m1, and if you calculate the slope of this line m2, in both cases, so if these two lines are parallel, means their slopes will be equal, m1 equal to m2. Okay, and if we are here, then the same thing, when two lines are, so if in a coordinate system there are two lines, either they will equal, either or they will intersect. Suppose they are intersecting, suppose we have a line, okay, and they are intersecting. So suppose this line intersecting this L2, so there is possibility that whatever the angle is becoming here, it could be 90 degree or different from 90 degree. So suppose the case is these two lines intersecting at 90. They're intersecting at the angle between these two lines is actually 90 degree, or in different word you can say these two lines are perpendicular to each other. So in that case, suppose the slope of line is m1, of L1 is m1, and line L2 is m2. In that case, the slope is, so these two lines are perpendicular to each other. The case is m1 into m2 is going to be -1. Okay. Now the next thing is representation of line. So more generally, as we
So
said,
is that a formula m1 dot m2 equal to -1?
It is a formula for perpendicular
this is
lines.
the formula. This is the itself a formula checking to be these two lines are perpendicular or not.
Okay, thank you.
Okay. So next thing is now the different kind of representation of line is there. The first thing is slope intercept form. So suppose you are able to write equation of a line is written as y is equal to mx plus c in this fashion. If a equation of a line is written in this fashion, so this portion is actually slope will give, and this portion is give the y-intercept. What do you mean by y-intercept? So suppose you are able to draw a line, suppose this is x-axis and this is y-axis. So how much this distance is there? This is actually c, and this is your slope. It has slope m, and this is y-intercept. Where it is cut the y-axis, that distance is actually the y-intercept. Okay. And suppose, for example, I have equation of a line, let's say 2x plus 3y plus 1 is equal to 0. And I want to find the y-intercept and the slope of this line. Just change in the slope-intercept form. That is, 3y is equal to, you can write minus 2x minus 1. Okay. And y is equal to, you can write 2 by 3x minus 1 by 3. So now this, now just you can compare with the y is equal to mx plus c. So here m is actually your minus 2 by 3. So slope is of this line is actually minus 2 by 3, and y-intercept is this one, minus 1 by 3. So m is going to be minus 2 by 3, and c is going to be minus 1 by 3. So y-intercept is minus 1 by 3 and slope of the line is minus 2 by 3. Now slope-intercept form. Now there are different of representation, or try to find the equation of a line. So this is slope-intercept form. The general form of equation of a line is kind of ax plus by plus c is equal to 0, as I have written. So this is general equation of a line, and this is slope-intercept form. And there are two forms we just wrote, and there is another thing is, suppose now we want to find some equation of a line where 2 points is given. Suppose you have a coordinate system a and b, okay, and let's say this is x1 y1 and this is x2 y2, okay. So I want to find equation of a line which pass through these 2 points. So how you will find? So for that, you can compare with the slope-intercept form itself. This suppose equation of the line is y is equal to mx plus c. Suppose we have line this one and we have this y is equal to mx. Suppose this is the equation of line. So what we needed in this equation, we don't know m and we don't know c. So how we'll find these two? So m is actually slope of the line. So suppose we have already given these 2 points, so you can calculate the slope of this line which is passed through these 2 points, which is, so in that case y2 is actually, m is actually y2 minus y1 upon x2 minus, this is your word. Okay, now we want to find the intercept, y-intercept. So in that case, how we'll find? So I think sir have given the derivation when we have 2 points and the equation of the line, how we will find. The formula is generally we say y minus y1 equal to slope y2 minus y1 upon x2 minus x1, as here x and x minus x1. So this is called 2-point form.
Sir,
Yes.
So could you please explain how what did you put at the place of C?
So is y minus y1 is equal to m into x minus x1. Then I didn't get that.
So actually, whenever you have given 2 point, okay, x1, y1 and x2, y2. So how you will find the equation of a line which pass through these 2 points? So generally put in this formula. So from here, you can, if you want to find the y, see, I just wrote the slope here. You can compare the same slope is here. I just forget to find the c. So from here, you can calculate how we are finding. So, okay, so what is going to be here? You can write y2 minus y1 upon x2 minus x1x plus. I think I'm missing something.
Sir, actually,
Sir, I
the
think
formula is
last-
y minus y1 by x1, x minus x1 equal to y2 minus y1 by x2 minus x1.
Sir, I think y2 minus y1, we would not plus, we would multiply x1 minus x2.
Y2
Oh,
minus
yeah,
y1,
actually, this
x2
is
minus
here. I
x1.
just
This
missed
is
that. This is
multiply
going
with
to be.
x2 by x minus x1. Yeah, that's why I'm
This is the formula.
confused.
Yes,
Yeah, I was when I was try to write C. So you have suppose this is the 2 point. So in that case, y minus y1 equal to y2 minus y1 upon x2 minus x1, x minus x1. Yeah, this is the formula.
Okay, you use the slope intercept form, right?
Yeah, I just missed that. I separately added here with the x multiplication.
Okay.
But here this is the formula. Now from here you can find the C as y is equal to, just make the first y minus y1 is equal to, this is y2 minus y1 upon x2 minus x1, x is here, and plus y2, okay, y2 minus y1 upon x2 minus x1, and this is minus x1. And now y is going to be your y2 minus y1 upon x2 minus x1x plus, here is y1 and plus, or if you take this minus is here, so this is minus y2 minus y1 upon x2 minus x1, and x is here, x1. So this portion is going to be your C, and this portion is going to be your M.
Okay, so yeah, got it.
Okay, that's why I started from here, but I just directly jumped to the formula because from here, yeah, I want to find this one, and it's needed some calculation to do like this. Okay, making like this and these all. I think in video, sir, have clearly mentioned how to find this in the case of.
Sir, can you please scroll down the screen? I want to see that C which you have taken out here. 1 minute, sir.
And the case is here when you have a point, suppose.
Thank you, sir.
Suppose you have a line, suppose you have a point here A, okay, which is given as x1, y1, okay, and you want to find a line which pass through this point A, which have slope m. In that case, there is a formula which is, you can say, 1 point formula. So in that case, generally you can write y, the same formula as work here, y minus y1 m x minus x1. This is the formula when you have, when you know the slope of the line and only 1 point. In that case, what is equation of the line is this one. You can see it is happening the same case. M is going to be this one, and the point is, you know, already. If you compare this one and this one, it is very similar. As here you can send this one this side. This is the same kind of thing, only the C expressed here in the very big expression, and here is differently M will included. Okay, now these two are there, and so different kind of representation there. General equation of line we directly. Now perpendicular in general form. Okay. Equation of a line of a perpendicular line which pass through or pass through a point. So these are just if you have a, suppose you have a line L, okay, suppose equation of this line is given ax plus by plus c is equal to 0, and suppose you have another line M which passed through this point. Let's say we have a point A which is x1 y1. I want to find the equation of this line. We have information is given that equation of this line is this. What is the equation of this line? Okay, so in that case, how we will find? So again, from this line and these two lines are parallel. Information is these two lines are parallel. In that case, what is the equation of this line is going to be? So we have equation of this line. Change this equation in the y slope intercept form. That is y going to be your y is equal to minus a by bx minus c by p. So from slope intercept form, just find the slope of this line. So this is going to be your m, slope of the line. This is m. Now you have, so these two lines are parallel. That means slope of this line is also m. So using 1 point form, as we just now wrote, so equation of this line is going to be your y minus y1 equal to slope of the line minus a by b x minus x1. When you have equation of a line, you want to find the equation of a line which is parallel to given line and which is passed through the point. A point is given. And what is, suppose the case is here. Suppose you have a line and you have a perpendicular line. Equation of this line is given equal to 0. Okay. And you want to find the equation of this line which pass through. Again, you have some information, extra information is given that the point passes through x1 and y1. What is going to be the equation of this line in that case? Again, you can find the slope from here, which is minus a by b. Okay. Minus a by b. Now, slope of the perpendicular line is m1 into m2 is equal to minus 1. Okay. Suppose slope of this line is m1 is equal to given. Suppose slope of this line is m2. So m1 is minus a by b into m2 is equal to minus 1. Minus 1 minus will cancel out.
B
so
by
m2
A.
is going to be your
B by A.
b by a. Now again you can use the point as y minus y1 equal to slope b by a x minus x1. So as only this 1 point form, the main thing, that's why I just directly jump to this point, 2 point form and 1 point form. Using these two find whatever you have information is given, you can use them and directly find the equation of line of parallel and perpendicular lines. Okay. Now, next thing is, I think only one thing is remain, that distance between two parallel lines. So again, I am not going to derive the formula. I'm just directly write the formula, because in this week 2 only the formulas are given, and that is not tough to remember. That only just remember the slope intercept form. Use this to every equation, and one thing extra, remember the 1 point form or 2 point form. That's all enough to do everything like finding the slope or distance, or only remain to be the area of triangle, that formula, bisection formula, distance formula. And okay, for related to the equation of a line, only 1 point form, 2 point form, and slope intercept form is enough to deal with any kind of thing. Yeah, one thing extra is distance between two parallel lines. So there is two things: distance between suppose you have a coordinate system. So suppose you have a line, so and here is a point. So there are two things. What is distance of this line from a point, and another thing is what is distance between two parallel lines. So one by one, anyone can unmute yourself and give the formula. Suppose this is a point x1, y1, and you have line ax plus by plus c is equal to 0. What is in that case the distance of the point from this line is, what is formula? Writing to be d as mod ax1 plus by1 plus c. What is that formula? Upon
Under root of a square plus
Under
b
root of
square.
a square plus b square.
a square plus b square. Yeah. This is mod of, just substitute the values of x1, y1 in this equation and divide with the square root of the coefficient. This is the formula. And the same thing, the distance between two parallel lines is just find the point on any one of the line and take the distance from the another line. Or what is the formula directly to find that? Find the slope of this line, right? I think
we just have to get the difference of the constant term and divide it by the same thing.
Yeah, root a square plus b square.
That is difference
Yeah.
of C1 minus C2 mod.
Mod
or
of
C2
C1 minus C2. So suppose you have equation A1x plus B1y plus C1 is equal to 0 of this line, and this is A2x plus B2y plus C2 is equal to 0. You have two different parallel lines. So equation, so distance between these two parallel lines is just take the difference in between them and divide with the coefficient as. So here is not A2, B2, C2. Here is the same coefficient will come.
B will be the same. Yeah, right. Yeah.
Because the reason is they are parallel.
Yes.
B1y, and this coefficient only these two will different. So what is this? This is the y-intercept, you can say. Y-intercepts are different only. Otherwise, see that these two are, so slopes are equal. Only what is different? The y-intercept is different. That's why you are taking the, if you are parallel, you are taking the parallel line which is parallel to x-axis. In that case only, see that only the taking the difference of the y-intercept. And here is square root of a1 square plus c1 square.
Here I have a doubt.
Yeah.
Sir, if one equation is twice the other of equation, multiple, then you first found the multiple and then make both equation as same.
Yeah.
And put A and B.
No, if one line is multiple of the another, it will represent the same line, right?
Yes, A1 and A2 are different now for both lines.
No, in the both line, if lines are parallel, in that case a1, a2 not different. The coefficients of the variables will be the same, only the constant terms will be different. Variables, coefficient of variable, here is b1 will be the same, here is b1 will be the same, here is a1 and a1 will be the same, only the constant terms will be different.
Yeah. Okay.
And in that case, take the differences between the constant and divide with the square root of the whatever the same coefficients are coming. Take the square root of the a1 square plus b1 square and square root of these two. Okay.
Yeah. Okay, sir.
So this is all about I think with the week 2.
Sir, can you please consider an example?
For example, you can take, like, let's say
let's say 2x plus 6y plus 8 equals
2x plus 6y plus 8 is equal to 0.
and
Okay.
next one is 4x plus 12y plus 16 equals to 0.
60 equal to 0.
Here C1,
So actually this, so
C1
no.
is 8.
So here is these two lines represent the same. Like this is the same representation, no?
Yeah.
This line is the same line. Not these two lines are not different.
They are parallel lines, that's why.
Yeah, these are parallel. So actually these are, see, you
No,
can
sir,
take the
these are-
common 2
these
from
are-
those sides.
So these are overlapping lines.
Yeah, okay. In differently, you are saying overlapping lines.
So distance between them is 0.
Distance between them is 0. As suppose this
so
is
these
this is
two
the
are,
line. Yeah.
Okay, I was saying no, sir. In that case, the things will be very different. When they are overlapping lines, the first thing is the distance will be 0 between them, and the second point is they will have so many solutions. That is, infinite number of solutions between them. Whereas if the lines are parallel, as you said earlier, like I mean to say, when the coefficient of x and y are same, y are same, and the constant terms will be different. In that case, the lines will be parallel, so there are no common solutions, and distance will be there. So that's it. I just want to make a point so that she can understand.
Yeah. That's the meaning. Yeah. Actually, yeah. In the solution terms, you want to say if this is in this case, you have infinitely many solutions. But in the parallel case where the coefficients say constant terms are different, in that case it have no solution. In the solution case, solution means what? There will be a common point which satisfy both equations. That's the meaning of solution.
Yes.
That's the meaning of solution, means they have a common point somewhere which satisfy the both equation points when we substitute.
Yes. Yeah,
But
correct.
when these two constant terms are different, in that case there is no solution. Otherwise, when the constant terms see that this is just multiple, you are multiplying the first equation with 2 and getting the same. And that's the thing here. If you take so these points are actually overlapping. These lines are overlapping lines, and that means on the same line another line is passing. It have infinitely many solutions, and in that case you can say distance is 0.
Yes.
Different. Okay, now somebody's have doubt on some practice, the practice and graded have. If you have, you can please let me know. If you have some week
Sir,
for.
I have a doubt from week 2.
Okay.
Sir, can we write C as capital C minus capital B? Or for slope intercept form?
Slope intercept form y is equal to mx plus c. Okay.
Here C can be capital C minus capital C divided by minus capital B.
Minus capital B. Okay, from the general case you are trying to reach the slope intercept form.
Yes.
So yeah, you can write it as now by is equal to here is minus ax minus c. These are all capital. If you are getting confused with the capital, so this is capital C minus capital ax minus capital C, and y can be written as minus a by b x minus c by a. Sorry, c by b. So actually the small c, you can say in the from slope intercept form, you are taking this one is small c. So this is small c is actually this one. So small c is actually
we can
minus
write this
capital C
anywhere where we have to find the constant. We can use this anywhere.
You can use this is your general equation. From general equation you are trying to reach the slope intercept form.
Yeah. Okay. If from here also m equals to minus a by b.
And m is equal to minus a by b. Abhishek wants to say something, I think.
Yes, sir. I have doubt in antisymmetric and asymmetric. If you can you please explain? I'll make a quick note of that.
So in the pictorial form, I will say,
Yes, sir.
let's say, yes, a relation on S cross S. So I just say that you can write as these two form S cross S as S1 is S is this one, S is this one.
Yes, sir.
So anti-symmetric and and asymmetric says in the suppose this is the point where AA, BB, CC will come. Okay.
Yes, sir.
So anti-symmetric is this portion. Including this one. Including this this tilted line.
Including this line and the
including this line and this portion is actually will come anti-symmetric. Okay. And for asymmetric, remove this line, only this. Remove this line, only this will come.
Okay, sir.
This is asymmetric.
Okay, sir.
This is these two differences only. Only this line will not come. So if you see the asymmetric definition, if AB is there, then BA should not be in that relation. That means only this portion you are including. And if you see the anti-symmetric definition, if AB is there and BA is there, this says A and A equal to B should be. That's why this equal line, this points that reflexive, that A, B, B will used to come in the anti-symmetric.
In asymmetric, if AB is there, then B, comma A shouldn't be there in
Shouldn't be there. That is asymmetric.
Okay. And in antisymmetric, if A comma B and B comma A, then A is
equal to B.
A should be equal to B.
B. And the pictorial form, that's the represent. That's the that's why in the pictorial form I showed this one. This Y is equal to that equal. This line will include in this for the anti-symmetric, but for the asymmetric, just remove this line and just below of it, just take those. Okay.
Okay. Okay, sir. Thank you, sir.
And also, okay, AB is there. Okay, yeah, this is going to be estimating. Okay, this is all about. Anyone have doubt? Jessica wants to say something.
Sir, in SSE, if element C is not given, find SSE.
If C is not given.
M and C.
Oh, if you have equation mx is equal to
yi minus mxi minus c का whole square.
yi minus mxi
minus c to the whole square.
Whole square. Okay. If m and c is not given.
Yeah.
Then surely some extra information will be there. Like if m and c is not given, that means your line is not given. M and C decides the line, right?
M is the slope, so every line has slope.
So can you complete the question, like some information, extra information?
If fx is given, then it works, sir.
Yeah, if an equation is given, then we will find the fx.
You mean to say in place of mx minus c, we put fx, we can put.
Yeah, actually for that case, I minus f of xi. Right?
Sir also solved that same type of question in the solve with this session, instructor session.
In this case, yeah, in this week 3, I think, or yeah, in week 4, week 3, I think.
Yes, sir.
You have done it.
Week 4.
It was fifth question.
Yeah,
but it's okay.
Actually, see, if you are doing this, this is for if m and c not given, that means you are substituting the values this is the for the case y minus fx, yi minus f of xi, and take the square of it.
Yes.
And now for each value of I and substitute y and I and get the square root of each of that and sum them. This is going to be SSC. If m and c in not if it is not a line, it is any function, not only line. In any function you can now convert. Here is f is given.
Sir, in week 1, in of the question of activity question, there is mentioned partition of set something. Can you please explain what is this?
So yeah, partition of a set means when there is a equivalence relation in terms of equivalence relation.
Yeah, the whole term was like an equivalence relation partition a set.
If there is a equivalence relation, then that equivalent relation gives a partition. Suppose you have a relation R.
They cut a set in 2 parts.
In the parts. Okay, if you have a relation, equivalence relation, that relation actually divide a set in the parts. Like for example, I am saying, let's say transitivity, x modulo 2. You know already mod thing. On set of natural number, okay, on a set of integer, I will say two numbers a and b related to each other when a mod 2 is equal to 0 and b mod 2 is equal to also 0. I think, the relation is like this. Set of integers, we are defining a relation. A, take the mod of a mod 2 is also 0, b mod 2 is also 0. So how then is this relation is equivalence relation?
You mean greatest common divisor of a and b is 0?
Greatest common, modulo means modulo already is taught.
It means
whenever you are dividing with 2, it is gives the remainder 0. That means a is actually the multiple of 2, b is a multiple of 2.
Yes.
So is this relation is equivalence relation?
Yes.
How can you check that? Set of integer it is.
Positive, reflexive, and symmetric.
So check for the each element of the no, I think if 1 is there, no, it is not. Okay, 1 is not there. Because if you divide 1 with 2, what is going to be the remainder?
1 with 2.
1 itself. So 1 will not come, right? As if you divide with 2, it should give 0, then the element will come. So in this relation, 1 is not there. So it is not going to be reflexive. Let me give the another definition. Some relation like I'm collection of family member, or simply say okay, or simply I am defining a relation. Let's say yes is the okay. Where is that? Yes is the collection of lines. Okay. Yes is the collection of lines. I am defining a relation on the coordinate system. Where is the collection of all possible line in the coordinate system? All possible line. Okay. So S is the actually collection of all possible line. So is this I am defining a relation, two lines are related when they are parallel to each other. Now, is this relation is equivalence relation?
Yes, it can be.
Yeah, actually this is a equivalence relation because one line is itself parallel. So it is a reflexive. symmetric is one line is parallel to another one. If
Then-
this line is parallel to
Yeah.
this one, that means this one is this one. And transitive means suppose this line is
Yes,
parallel to this
transitive
one,
also.
and this relation is parallel to this one, then these two are parallel. So that
Yes.
means this is a transitive. So
Yes.
now see, now it is now happening a partition on this. Suppose you have a line, this one, okay? Suppose you have a collection of line, okay, this one. And suppose you have this line. So the one partition is on this set, collection of all line is this. Suppose this is a line, so it will partitioning like this. Okay, what is the partition? That this is a line, so I am taking collections of line which is parallel to only this line, Suppose you have L1, so
Yeah.
L1 I am taking the collection of now of this set which is parallel to only line L1. Okay, now suppose another line is here L2, so I am taking the collection of those line which is parallel to only L2, right? Only parallel to L2. So see that what is happening, a partition on the collection of line it is happening. A line which is only parallel to L1, a line which is only parallel to L2, a line which is only parallel to L3. So see that this is a collection of line on this, the partition is happening. L1, L1, L2, L2, different partition is happening. Only a set, the first partition is, which is the collection of line which is parallel to L1. This is another, this is another. So this is a partition
Yes.
is happening.
Got
That's
it.
the meaning of partition.
Yeah, got it. So it is applicable for only equivalence relation.
Yeah, it is applicable only on equivalence relation.
Yeah.
Okay, thank you so much. Anyone have doubt, please let me know. Otherwise, we'll close the session.
So we will be having a similar session for week 3 and week 4 also.
Yes.
Okay.
Yes.
Thank you so much, sir. It was very informative. Today's session was
Okay,
very
hope this session will helpful to all of you.
Yeah. So
Yes, sir.
the,
Thank you, sir.
the when do we have the continuing this thing, sir?
Sorry?
When do we have the next session?
It is on the Friday morning.
So Friday morning. Time.
7 to 9.
It is in the calendar itself.
Okay.
Sir, I have a request. I'm like an international student. So basically, what is happening is I was going through the WhatsApp messages, and someone has posted that they have got something called SCT. I don't know the meaning of it on email. Although I already emailed to the admin department of IIT Madras, and I have just got the reply that okay, something. Just give me a moment, sir. Let me check what is the reply. And it just says that, okay, dear student, please wait, you will receive it. So although I have replied to it, I just want to make sure that, and also ask you that, is it mandatory for me to do that SCT? And if not, is there any
compatibility SCT, na? System compatibility test.
Yes, perhaps.
So are you taking any
yeah,
programming exam? Are you giving any programming exam?
No,
Like-
sir. I'm like a qualifier. I have to sit in qualifier exam.
Sir, may I answer that? I know actually.
Yeah, sure.
Yeah, so that is basically for the students who live abroad. So those students who are not going to the center, for them that computer test is required. So if you are going to the center, if you have applied to go to the center, then that test is not for you. It is only for the students who don't have a center around, and therefore they require this SCT test for their laptops or PCs.
Yeah,
Okay,
for
thank
the
you.
proctored exam. For the
Yes,
proctored exam, this is.
Yes, sir. Thank you very much, firstly, for the answer. Sir, we have to give the proctored exam only because we don't have, IIT Madras don't have any centers in United States. So basically, because we are the one who just interact with teachers only like you. So I just request you to, if at all there is a way that you can escalate this matter so that we can receive the things early. कि अगर मान लीजिए कि कुछ गड़बड़ भी होता है तो we have the time to rectify that. At the last moment they send the things and they say like, okay, fine, you have to do it within this many days, so it becomes difficult. So अगर आप request मतलब अगर आप इसको थोड़ा सा escalate कर दें तो it will be easy for me to do the things. ये request है.
Okay, but this is totally operational. Okay, we'll consider, so that your query is need to this SCTs need
Yes,
to
sir.
be earlier, make a information earlier. Is that
Yes, whatever the email, because some of them have already got it. It's just that I have not received, and I believe a few more must not have received it. So I have not received it. I have already emailed, and I told you the reply of that email. So बस मैं ये चाहता हूँ कि अगर आप क्योंकि हम तो आप ही से इंटरेक्ट करते हैं ना, उनसे तो कर नहीं पाते, ईमेल के थ्रू बात होती है, तो अगर आप हमारे बिहाफ पे कह सके कि भी आप भेज दें, सो दैट कि लास्ट मोमेंट पे कोई ग्लिच हुआ तो हम उसको फिक्स तो कर सकते हैं ना. अब एकदम आप 26 को पेपर है, 25 को भेजेंगे और मान लीजिए कुछ निकलेगा, फिर हम क्या करेंगे, कहाँ भागेंगे लास्ट मोमेंट, फिर आप कहेंगे कि आप लास्ट मोमेंट पे बता रहे हैं, लाइक
yes, CT should be earlier, at least. I think no, one thing is because this CT is near to exam, because see why, the reason is it is maybe 5 days, because
maybe you are
right,
saying something, some other things cannot.
Yeah, some other things like some suppose your system is suppose you did 10 days before, and after doing the SCT, your system got some glitches are there, again facing some difficulty, or your system is not working.
Right.
But you said that okay, I did SCT, but I am now unable to do this, so that's why it is kept on near to exam. If I am answering.
I agree with you, sir, but it don't match because some of them have already got to maybe 2 days back. But anyway, sir, I just request you कि वो important नहीं है, बस ये है कि अगर वो हमें मिल जाए, लास्ट मोमेंट तक वेट ना करना पड़े तो ज्यादा इजी रहेगा. अगर आप हमारे बिहाफ पे पहुंच सके तो अच्छा
लगेगा. I will tell. I will in the meeting we used to be tell. Yeah, surely.
Thank you very much, sir.
So will you be the one taking the Friday session?
I think probably Subhasis will take.
Okay.
Subhasis. Yeah.
So one question last.
Yeah.
Sir, as I did the qualify exam in September, so I studied week 1 to 4 already. So I am skipping the practice assignment. So it will affect my grades or not?
Practice assignment only.
Yes, sir.
No. Then there is no, only graded is.
Okay, sir. Thank you.
Sir, so sorry, it's getting late already. I just wanted to ask that in the quiz 1 exam, will we be given the facility to use a calculator?
Yeah, it is TCS calculator only.
Okay, thank you.
Sneha want to say something? Yes, Sneha Kulkarni.
Yes, sir. Sir, I just had one doubt in activity question 1.7.
1.7.
Yeah, week 1, first question. 1.7, first question. No, yeah.
Okay.
I don't know how to, I mean, how do I approach to this? How do I approach the solution?
So in this question, 40 student, you have 20 took mathematics, 18 took statistics, and 16 took English. 7 took maths and stat. Okay. 7 took maths and English, 9 took stat and English. 3 took all 3 courses. So very quickly you can do right this one. Just now we discuss on this here, as here we discuss. We can quickly do also here by making this all. 20 think mathematics, 18 statistics, 16 English. So what is that? Okay. Okay, this one and this one. So let's say this is maths, this is English, and this is stats. This portion, see clearly, it is written 3 took all 3 courses.
Yeah.
That means this portion is overlapping, right? In all 3.
Yeah.
This information is 3 is given. Next is 7
took
took
maths
maths
and
and stat. So maths and stat is this one, and this whole thing is given 7. This is the portion, right? Math and stat.
Yeah,
In this 3 is already it is we have
that
information.
will be 4, right?
So this is going to be 4.
I got it, sir. I think that was the
Similarly
mistake I
this
went
one,
to.
similarly this one.
Yeah, got it,
Now
sir. Got it.
separately calculate this portion already.
Yes.
Separately calculate
So
this
that will
one.
be
Separately.
20 minus the overlapping. I
Ah.
got it. Thank you.
Now added them and calculate.
Yeah, got it. Thank you.
Thanks, everyone. Thank you so much.
Thank you.
Good night to all of you.
Thank you, sir, for extra time. It's already 1 hour over.
Yeah.
Thank you, sir.
Thank you so much.
Yes, sir. Good night.
Thank you, sir. Good night.
Thank you, sir.